Hello guys, welcome back. And as I promised, this video we're gonna try to the exercise and make sure you guys are familiar with this logarithm calculation. Okay, let's do it together. Please pause the videos and see if you can get the same answer as me. And normally, sometimes I make some mistakes, so make sure you can correct me on the comment if I make any silly mistakes. Okay, let's do it. So the first question is pretty straightforward. Just evaluate each of the following. The first one is, remember last video we said, okay, the base is 10 and the number we want is 1000. So we ask, what the power of 10 gives me 1000, right? Which means 3. Okay, 10 times 10, 100 times another 10, 1000. And this one, so 64, 2 to the power of what is 64? 2 to the power of 6 is 64. Okay, because 2 to the power of 5 is 32, right? 2 to the power of 4 is 16. So 2 to the power of 6 is going to be 64. And in here, this one is a bit tricky because we involve with fractions, but we always can write fraction into the power of negative stuff. So if we can do this one, so it means half times itself 4 times, and the half just 2 to the power of negative 1 and 4. So it's going to be 2 to the power of negative 4, right? In here, so it's going to be negative 4. And again, this example is 1 million. 10 to the power of 6 is 1 million. And in here is 1 lower 1000. So in this one, it's 10 to the power of negative 3. We just write negative 3 over here. In here is 1 over 128. We know 2 to the power of 6 is going to be 64. So times another 2 is going to be 128. In this case, it's going to be 2 to the power of negative 7. So you just write negative 7 over here. Okay, that's pretty straightforward. And for next one, for each of following, just like ordinary, express each of following as the single term for logarithm. This one using like multiplication, so give us 6, and this one again multiplication, this one multiplication, so it's essentially the same thing. This one again multiplication, and this one we use division, so it's going to be 32 over 8. So this one going to be 4. Okay, I write 4 over here. And this one is multiplication, multiplication, multiplication together. This one will be multiplication and division. Okay, and this one becomes log e to the x squared minus y squared over x squared minus y squared. So going to be log e 1, which is just 0. Okay, for this one. And for the g, it's just like put 2 over here, put 5 over here, then do multiplication again. Okay, so you have to convert the power first. And now for question 3, they tell us to find the logarithm, inside of the base. In here, the x just 10 to the power of 2, so it's 100, and this one 2 to the power of 6, this one just like 2x plus 3 equals 1, because for this question, we need to make sure your both side, okay, both side, you take the e for the base equals 0, so it's 2x plus 3 is 1. Okay, then solve for x. Okay, and rest of them are essentially the same thing. And for question 4, it's becoming a bit harder because both sides they got log, and you have to do a bit simplification to get the x value. The essentially here is quite tricky. It becomes log e, then 8 to the power of 2 over 3. Okay, this one is quite annoying. So sometimes if you do 8 square, then cube root, or you do cube root, then square. Both way works, but personally I prefer this way, because if you can convert 8 into base 2, then you realize this become much easier. It's just like 4. Okay, but if you do this again, you can, it's 64 with cube root, so it's again it's 4. So same thing. My suggestion is for this type of numbers, convert into the smallest base if you can, then to see what's going on here. Okay, let's keep going. For question 5, they just ask us to write something in terms of A and B. Okay, so just involve with the literal numbers. We don't know, but just keep writing it. So just make sure you write your final expression in terms A and B. For example, this one is log 10 square root of A, makes sense? Minus log 10 square root of B. So it's just like log 10 square root A over B because minus becomes division, okay? And for this one, make sure you were not tricked by this weird expression. It simply just means log 3 to the negative x, so it's just like negative x, okay? And from 8, 9, 10, and 11, this sort of things is become harder and harder because after up to question 7, it's pretty straightforward and you need just use it. You just need the basic laws. But from question 8, it's try to combine more about these things in terms of one question. So that's the final answers type of question. First one, they ask you to solve this guy, okay? The first step we should is move 2 over here, become like square, right? Then it's just x squared minus 2x plus 8 equals x squared. Then just solve for x, okay? Same thing over here, just 5x over 3 minus 2x, just is log e equals 1. Again, we use the base e, okay? E to the log e, 5x over 3 minus 2x equals e to the power of 1. So essentially it means 5x over 3 minus 2x is e instead of some people just gonna give me this. Okay, 3 minus 2x is 1. This is wrong. Okay, this is incorrect. This one is the correct one. Should work on. And for this part is to the x to the power 4 is 81. So we need to solve for x. And this one is just like x to the power 5 is 1 over 32. Okay. In here, some people might think, okay, sir, this one is even power, so x can be plus or minus 3. But just make sure x is on the base. Our base is always greater than 0, but not equal to 1. So only 3 can be taken. Okay. Okay, let's get back to 9. There is one thing I have to emphasize, it's this guy. So hopefully you still remember this guy, how to solve it. This is use substitution method, okay? Which means we make maybe like y be the ex. So it's 8 over y minus y equals 2. So it's 8 minus y squared equals 2y. And then just like y squared minus 2y plus, minus 8, just 0. It's greater than 0, of course. And okay, plus 2y, plus 2y minus 8 equals 0. So essentially it's the same thing. Same thing considered as in chapter 4 polynomials, right? Chapter 4a or 4b, solve for quadratic equations. So you have to use a cross product to get the ideas of this guy, okay? And this comes to our final questions, which is this guy. Solve for n. This looks pretty tricky, but we can do it again without using cas, okay? Let's look at the right hand side. We just make half over here, just keep it at the first. Then log a 24 minus this guy 0.375. We may prefer two fractions, so we change to 3 over 8. Okay, and again this one we change to log a 3 to the power of 6. Okay, now we apply the index law, so it means half log a. Okay, let's bracket over here. So it's 24 divided by 3 over 8, which means times 3 over 8. Make sense? and divide by 3 to the power of 6, which means times 3 to the power of 6. 1 over 3 to the power of 6. Then let's do some simplification here. So there is 1, there will be 8, and that's it. So it's just going to be half log a, then 64, and 3 to the power of 6. Then we make the half over here becomes log a, then square root of 64 and 3 to the power of 6. So it's going to be log a, okay, I write over here, it's going to be log a, square root of 64 is 8, square root of 3 to the power of 6 is going to be 3 to the power of 3, right? So going to be log a 8 over 27, which means our n over here is 8 over 27. Okay, this is how we do it. Just do step by step. If this type of question occurs in exam 1, it must have the really nice number, and you should get the really neat final answers. Okay, hopefully this video help you to to emphasize my point over here. You have to be familiar with the log calculation. For next one, we're going to talk about the graph for log functions and with transformation, and I will help you guys with some trick to help you draw the logarithm function. Okay, hope my videos helpful to help you to prepare the final exam, or even like help you summarize a bit confusion part for the math method. And hope you guys enjoy. Okay, I guess I see you guys next videos. Bye bye.